Educational Communications and this station present Environmental Directions with Nancy Perlman. On this series, we explore the effects of human influence on the Earth's ecosystems and discuss solutions to environmental problems which affect the quality of life on this planet. Environmental Directions gives you the kind of information you need to help you participate in decisions impacting your community, the nation, and the world. Now, here's your host, Nancy Perlman.
Hello. For the next half hour, we are going to be talking about dinosaur extinction, paleontology and scientific acceptance of new discoveries, volcanic eruptions and asteroid impacts, as well as sexism in the scientific world, with my guest, Gerta Keller. She is a professor of paleontology and geology emeritus in the Department of Geosciences at Princeton University, where she has been a tenured faculty member since 1984. She has placed over 260 scientific publications in international journals and is considered a leading authority on catastrophes, mass extinctions, and the biotic environmental effects of impacts and volcanism. She is the author of The Last Extinction, the real science behind the death of the dinosaurs. Welcome. It's a pleasure to have you with us.
Thank you.
Your story is absolutely fantastic. It should be a must-reading for everybody because it's part scientific, it's part detective story, it's part of a personal odyssey. We all have heard about the dinosaur extinction, one of the major extinctions on the planet. I think it's the fifth extinction, isn't it? About 66 million years ago?
That's correct.
About 70 species went extinct, but for decades, people believed a scientific theory that an asteroid caused it, and yet your discoveries showed that no, it was really volcanism. Can you explain the difference of why people in the scientific community thought an asteroid created the extinction and why your discoveries showed that it wasn't?
Yes and no. I can show that what the extinction really is, it's both. First of all, what was first discovered was that there was believed to be an asteroid. And that was, of course, by the Alvarez, Nobel Prize winner, and his son, Walter Alvarez. They believed it, and they would never change their minds. And they still haven't changed any minds. But I already was studying dinosaurs before 1980. And at that time, everyone was hearing about the big hoopla of how the dinosaurs went extinct because of an impact. Impact meaning that an asteroid crashed into, at the time it wasn't known where, but eventually it was found out it could have been Mexico. So the question then was, what killed the dinosaurs? And I should go back now to before I went into working in India, because at that point I tried to work in India, but I did not know what to do with volcanism. It was not my field, not yet anyway. So I went to look at the environmental changes. So of course, the big topic was always climate change. And the question then was, okay, what happened? We know that there was global cooling and global warming. You could have both. But what we found out was that already 300,000 years prior to the mass extinction, climate warmed very rapidly. And the reason for the warming actually was the Deccan volcanism, meaning Deccan means that it is the mountains, the volcanic mountains.
And that comes from the Deccan Plateau in India.
From the Deccan Plateau in India, exactly. To go on with that part is that the climate change then, I didn't mention it before the warming started, there was almost 7 million years before, it was actually quite cool and alternating cool-warm. There was not much volcanism going on during that time, but then when it started kicking in, that's when climate really started to change. And it started to become problematic also for the dinosaurs, because dinosaurs, if you have a lot of volcanism, as we found out very quickly, then the dinosaurs will have a problem. And in particular, and so it went on for 700,000 years. Sometimes the volcanic eruptions stopped for a while, and everything cooled off a bit, and then it started in again.
So in essence, the real cause of the greenhouse gases came from volcanic eruptions in the west central part of India, and the lava and those gases, it flowed over 1,000 kilometers to the Bay of Bengal into the Indian Ocean.
Absolutely. Absolutely. It was a fantastic discovery, in fact, that we made on that. It became so that we could, well, I should backtrack and say I was lucky enough to get to India in 2005. And that's when Indian scientists discovered that there were some forams, or foraminifera, the tiny species that are only about a few millimeters in size.
You talked about these plankton forams. They're
right.
Microscopic organisms, and during the extinction, most went extinct, but one species survived?
Yes, and it's still living today.
And you went out and looked for these because they apparently, for scientists like you, were determining factors in what happened when. And it wasn't always so easy to get these samples. You've done your paleontological research from many different places, from Mexico, Tunisia, Israel, Egypt, India.
All over the world.
It wasn't always easy to get samples. Particularly, you had problems in Mexico trying to get the samples from the asteroid impact area because the scientists wouldn't share the cores with you to do the scientific research.
Yes, that's true. That's very true.
I always thought that scientists would share their work, share their research, and yet you had tremendous problems for decades getting not only material to do your research, getting funding to go do your research, but presenting the research. And before the internet, you had to get many, many more publications, articles in peer-reviewed publications, and the peer reviewers disagreed with your theory and discoveries, and so they wouldn't even publish your work.
No, they did in the end. In one case, it took almost 10 years.
Your descriptions in your book of what you went through to try and let the scientific community know what you have found was amazing because you weren't afraid to name names about the people who would heckle you at scientific conferences. They wouldn't even let you present your papers. They would call you sexist names. I'm amazed that you were willing to persevere and continue.
I'm a Swiss, that's why.
And you described that odyssey where you grew up in poverty and you decided to not do what all women were supposed to do back then, like just take care of the house or have menial work, and you decided to go around the world, and you landed in San Francisco when somebody said, oh, you can go to community college for free. That's a real testament to our college system here.
Absolutely. It was fantastic.
And you also talked about the support of your husband, a very renowned mathematician, and how he was instrumental in helping you overcome all these difficulties in the scientific community.
That is not quite correct. I overcame all my own difficulties. He was a mathematician, and he loved the dinosaur stories, and he loved nothing more than to telling everybody all the stories that came about because of my work. But that's what he loved to do.
It's good to have somebody who enjoyed your story. So let's continue that story of these plankton forams. Why were they so important to your conclusion that it was volcanic eruptions and not an asteroid that caused the extinction?
Okay, there are two things there. First, we discovered that it was these tiny forams. And nobody in India had ever bothered looking at those microfossils. And that's how I was invited to India to check it out. And I couldn't have been happier to see, my God, this is the first discovery in India that these microfossils exist. And it became a big deal. And also, of course, it was the first discovery of the mass extinction in India. So after that, there were many other things that we found out, and various other discoveries of how the Deccan volcanic eruptions actually flowed through from the high plateaus in India all the way down into the basin. And then, of course, you could essentially see where the mass extinction ended up. It was really eureka moments, one after another.
You were fortunate to have support of some of the scientific community. Eventually, it turns out that another scientist who believed in the asteroid theory was able to do some chemical analysis that convinced him that your theory was the correct one.
You mean the iridium?
Correct. Tell us what that is.
Iridium is a rare earth element, and it's very rare earth, but it comes out, it's rare earth because, number one, because it is in asteroids, but it is just as common or abundant very deep inside the earth, and it only comes out when you get very giant volcanic eruptions that will erupt with the iridium. I never really believed that the iridium that the Luis Alvarez theory proposed was in fact from an asteroid, and I did not know enough of the chemistry in order to find that out, and it took me until about 2018 until I met this one guy who was an astrochemist, a guy who knows the chemistry of asteroids, and his name was Munir Humayun, and he worked for NASA, and he worked for NASA in Florida State. That is a big place for NASA work. He came to my talk in Florida this one day, and with my husband, who was doing the mathematics. So we gave actually joint talks. And he was telling us that how did I believe he was an impactor, meaning he believes only in asteroid impacts. And I didn't mention that, but I asked him, if you know all that much about the iridium, I have been looking for a person like you who knows about the chemistry of asteroids and at the same time of deep inside the earth. And I would love to have you take a look at it, and I have thousands of samples, and if you need any of these samples, I will give them to you as much as you want, and we can find out just what the iridium is. And the next year he came back and he said, okay, I thought about it a lot and I found a good student, so I will do the work with my student and see what comes out. It was fantastic. It was COVID time just after he started, and we gave the first talk. He and his student, I should say the name, her name was Stephanie, and she was actually a professional tennis player at one time. He became ill and then became a very fantastic scientist. So with Stephanie and Munir, they gave the talks, and it was a hallelujah moment for many people, because a lot of people never believed in this iridium anomaly.
Collaboration is so important, and when you get people from different fields acknowledging the significance of the different discoveries, it really helps, doesn't it?
Absolutely. It really did. Except some people absolutely hated the whole room full of it because they didn't believe that this was the impact theory.
But eventually people have switched to consider that
Absolutely.
the impact theory was not the cause of the mass extinction, although the mass media loves it and people still think that that is the cause. You have shown that it's not, and you have so many more stories to tell. You have great stories in your book, The Last Extinction, The Real Science Behind the Death of the Dinosaurs. We're going to talk more about mass extinctions, why it's important for us to care about what happened in the past and what is happening now when we return in a moment with my guest, Gerta Keller.
Environmental Directions with Nancy Pearlman continues with further discussion of the world's critical ecological issues. For more information, you may call 310-559-9160 or go to www.ecoprojects.org. Now, here's Nancy.
I'm speaking with Gerta Keller, Professor of Paleontology and Geology Emeritus in the Department of Geosciences at Princeton University. I loved your book, The Last Extinction, The Real Science Behind the Death of the Dinosaurs. I learned about scientific theories, how scientists work together, didn't work together, learned about personal journeys. You've had so many experiences in your long life. You've been to so many different places around the world. What stands out the most to you? What experience do you still recall as very significant in your life?
There are numerous. I've had, I think, all the research, the scientists I worked with, the people that I had worked with, particularly throughout India, they were fantastic. They were more open-minded than anyone I ever met in the U.S. I probably should not say that, but it is true. As far as the impactors are concerned, they could never agree that there was an impact that predated the mass extinction. And that was, I think, the most important part that is still, how shall I say, who will believe the impactors who simply cannot accept there is evidence that is overwhelming compared to what they are basically proposing on a daily basis.
Your discoveries showed that the mass extinction of dinosaurs occurred about 200,000 years before the asteroid hit the Earth?
Yes.
The extinction was caused by the volcanic eruptions and the greenhouse gases caused by that, correct?
The greenhouse gases were caused by that, which is totally correct.
When did the mass extinction occur? When did the asteroid hit? What's the relationship?
The mass extinction occurred when the dinosaurs died out, as well as all the tiny microfossils. And Chicxulub hit 200,000 years earlier.
The asteroid hit before the mass extinction.
Chicxulub is essentially the asteroid. So let's say the asteroid hit 200,000 years earlier.
When did the volcanic eruptions happen that caused the mass extinction? When did the asteroid hit?
The volcanic eruptions that caused the mass extinction occurred 66 million years ago. The asteroid hit 200,000 years earlier.
Your major volcanic research was done in India, but you also went into Mexico where you wanted to do geologic investigation at the asteroid site. It wasn't always safe to do it. Sometimes you had to go and deal with drug cartels?
Yes, and we would make it in even when all Mexicans were afraid. We sneaked in occasionally, but then eventually you could no longer do it.
And what did you discover at the asteroid sites?
At the asteroid sites, that's the most important one just before the drug cartels took over. And that is, we discovered, I had a couple of students. They were undergraduates and very smart. I usually took 15 students with me on the field trips. And one day, these 3 students were telling me, you always tell us that there was another side to it, and that we haven't found yet what really happened to the impact spherules, which are these glass beads that fall out from the sky after an impact. And they said, okay, we want to find out, so tell us where we can go and find a good location. So I took them to a location that actually we had never gone to. It was relatively close, but we'd never seen it before. And I told them to dig at least 2 meters deep down the hill and try to find and dig until we would find something, namely the glass beads. And I was looking at the other students, joined them with their work, and then after about 4 hours, they came running and said, we got it. So we went back, and it was a eureka moment. You could not believe what you saw. It was 2 meters thick event of nothing but pure glass. First, it was the molten glass at the bottom, and then bigger, when it was cooling, bigger glass spherules, and then eventually they became smaller as they cooled more. But 2 meters of it, there was nothing else.
And so what does that tell us?
Those were the spherules that were hit when the impact occurred. That was it. And not only that, they were pristine. They had never been touched. Nothing had ever changed. And we found out that it was 200,000 years before the mass extinction.
That's the significant point, that the asteroid hit before the mass extinction.
Exactly. The mass extinctions occurred at the time of the dinosaurs, when the dinosaurs died out, and also the microfossils. The asteroid impact hit 200,000 years earlier.
We talk about the dinosaurs as being the 5th extinction. What were the first 4?
The first extinctions, well, that was the Chicxulub impact, was an extinction, but it was 200,000 years older.
Yeah.
That was the problem. That's the problem that still is problematic for all the impactors, because they will not accept that.
Why did it take so long for the scientific community to accept your research as the cause of the extinction?
Because everybody believes the story of the impact.
The media certainly helped with that story.
The media never went away. In fact, I just had a 2-hour interview with people who know impact, and they believe it every which way. They say it's impossible what I say.
But, of course, you have the scientific documentation, and it has become accepted. I'm very happy that finally your work is recognized for the discoveries that you have made. Non-paleontologists, geologists, chemists, and others is wonderful, because it really gives us a better understanding of what has gone on, what is going on, and why it is so important for us to know about all this. Why do you think your discovery teaches us about greenhouse gas and climate change, and why we have to do something now? Because it's really getting pretty horrible in terms of leading up to the next mass extinction.
Absolutely. I was always interested in climate change. I started working on that just when I came to graduate school at Stanford. There was one person who was very famous at the time. He was Nick Shackleton, a guy from England, an explorer at the same time. And he found out actually how you can make analysis from forams, the tiny critters that essentially are just in millimeter size and eventually died out. And it was a fantastic revelation to find that, and in fact it is still lasting today. And so it was a wonderful time to use this new method of using carbon isotopes. And I don't want to overload people with names, but basically it just helps us to realize what you can measure and what will come out, what will be the data. And in this case it was that you could actually create the measurements that would tell you the age as well as the value of these forams and how hot or cold it would get.
We know that during the extinction period, the rate of greenhouse gases 12 to 16 times peak volcanic eruptions during the dinosaur extinction, we have tremendous increase in greenhouse gases caused by human beings, and we should be concerned. We need to do something now, don't we?
Yes. It was in 2018 when I and a couple of my students decided we would look into what happened, when will the next mass extinction come. It was only 2018, and we wrote this paper. It's only about a few weeks ago that we actually looked at this paper again, and we said, holy moly, what did we do? We thought the extinction would take a lot longer. We thought we would have about a couple of 100 years before our climate change would become horrendously problematic. Instead, we know now, today, that we only have a few more years.
And people need to read your book to really understand why and how that has happened. In addition to learning about the extinction, learning about how one discovers how they occurred, what you went through as a scientist to get your theories accepted, you have interesting stories interspersed about your personal journey, about other people's journeys, about little things that we don't even think about. I enjoyed hearing about this Danish scientist Hansen taking crocodile eggs from Florida to Denmark. Give that story, because why should that be important?
It was important. Hans-Jürgen Hansen is the name, and he was always a very funny man. He could make jokes about everyone. One of them was when I was in a very awful situation leading a field trip with the impactors, and Hans-Jürgen comes by me in the field and he says, well, this is really fantastic. You've never met such a Danish bitch, because a guy had called me a Danish bitch right then. And the person didn't know that I wasn't Danish at all.
But this scientist took eggs, kept them in his coat on the plane, and by doing that, discovered that when at a certain point the shells hardened, and therefore they couldn't break out. And that happened to the dinosaur eggs during the extinction, where the shells hardened and they couldn't break out.
Yes, but the reason they hardened is because this Hans-Jürgen Hansen was injecting volcanic poison into the eggs.
Just what happens during a volcanic eruption.
Exactly.
Again, more proof that the volcanic eruptions caused major problems. Why did it take you so long to write this book? The book is excellent, wonderful reading, so much information.
It took me so long because, in a short way, I have had an editor of Penguin Press for 15 years. Every year, the chief editor would give me another version and then complain that it had too many stories, it needed more science, and she wanted only science.
I'm glad you have the stories. You have so much valuable information. The Last Extinction, the real science behind the death of the dinosaurs. It's available in all the normal ways that people acquire books, but how do they contact you? What is your website?
My website is gkeller@princeton.edu.
And that's spelled GKELLER.PRINCETON.edu. I'm so pleased that you finally wrote your story. It is great that the general public now knows what is really required to do scientific research, how to get that research accepted through the scientific process, hear about all sorts of fascinating stories of your own life. Thank you for sharing this with us. Thank you for being my guest.
And also thank you to my editors who have done so much work to help me along with it.
It's a team effort to get this information out. Thank you.
Thank you.
I have been speaking with Gerta Keller, Professor of Paleontology and Geology Emeritus in the Department of Geosciences at Princeton University. I'm Nancy Perlman. Thank you very much for joining us, and do tune in again next week.
If you would like free information about these environmental issues, go to www.ecoprojects.org or call 310 559-9160. Environmental Directions with your host, Nancy Pearlman, is a community affairs program of the nonprofit organization Educational Communications and this station.